Hello guys, today we're doing legal question 146, LRU Cache. The question is, design a data structure that follows the constraints of a least recently used LRU cache. Implement the LRU Cache class. So LRU Cache takes a parameter of integer called capacity. Initialize the LRU Cache with positive size capacity. So then it takes a class or a function, which is a get function. Return the value of the key if the key exists, otherwise return -1. It takes another function, put, update the value of the key if the key exists, otherwise add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. The function get and put must be each return an O1 average time complexity. As you can see here, LRU Cache put, so you put a value of 1 with a key of 1 and value of 1. The max capacity is 2 when you initiate the class. You put a value of 2, capacity of 2. You get 1, that returns 1. Then you put 3 and 3. You then get 2, that returns -1 because now 2 is the last one used, as they've used 1 here. So 2 is removed. Then you put 4 with a capacity, a key of 4, value of 4. You get 1 again. You get 3. 3 is found. You get 4, and 4 is found. Okay. Well, 1 is not found because you've called 2 and 4. So 1 is the last one used, and it's been removed. So yeah, you add 3, you add 4, 1 last removed. So the way we would do this is by initiating here a capacity variable and a map to store the values. And each time we use a value, whether we get it or put it, we set it as the last value added to the map. And every time we every time we use a value, if the value exceeds capacity when we get it, then we remove the last used value, which is the first value in the map. So let me show you how to do this in a whiteboard. So the first thing we do, we initiate the LRU class. So let's say LRU, which has a capacity and a map to store the values. So let's say capacity is now set as 2, and currently our map is empty. Empty map. Okay, next, let's say we want to set a value of, say, set 1 and 1, key of 1, value of 1. Then we put in a map, so now that has this, an array. And now let's say capacity left is now 1 because there's only 1 value in the map. Then we set another value, let's say 2 and 2. Then set it to the map. Our capacity is now 0. So let's say we want to get 1. Then we return a value which is 1. And if we want to now set another value, let's say 3, 3, 3, 3, we have to remove the last value, so we remove 1 and 1. We keep 2 and 2, and then we set 3, 3. So now it's 2, 2, and 3, 3. Now let's continue. Let's say now we want to get the first value in the map. So if we get 2, it returns 2, but as 2 was our least used value, now becomes the most recently used value. So we delete it from the map and we set it as the last value in the map. So now the order will be 3, 3, 3, 3, and 2, 2. The reason for this is so that the array remains consistent. Every time we use a value, we set it to the end, so that is the last value we delete, and we will delete the last used value, which will be now 3. Let me show you how it's done in code. Okay, so the first thing we do is we initiate 2 variables. The first one is capacity, and we set the capacity to the value inputted in the function call. So we say it's 2, this sets the value as 2. Then we set a map value, which will allow us to store the keys and values in the put function. Now with the get function, we have to check if the value exists. So we check if the map dot has, or if this map dot has key, then we have to first get the value of the key. So map this dot map, or let value is equal to this dot map dot get key. Then we delete the key and we set it as a last value, so we know this is the most recently called value. So map dot delete, or again this dot map, sorry, this dot map dot delete key. Then this dot map dot set the key, pass in the function and the value that we pulled from the old function. So now the value we've called that we've looked for, we set it as the most recently used value. This is to keep in order of least recently used keys, from least recently used to most recently used in the map. Then for the prototype put function, oh yeah, here if we don't find the key, we return -1 as mentioned here. Then for the prototype put function, we check if the key exists. So if map.has key, then we know we don't need to check the bigger the capacity, because we can just change the value of that key. So the first thing we do is we delete it. So map, oh wait, again, this dot map dot delete key, and again here this dot map as well. Else, if we don't have it, we check if the capacity is bigger or equal to. So if the map, so if map.size is bigger than or equal to the capacity, then we know we will exceed the capacity. So we remove the first value in the map. We do this by, again, this dot map dot delete, and then we get the map's first value by calling the keys, then getting the next value, so the first value, yeah, so the keys the next and get that value, get that key pretty much. And then after that, we just set here the new value. So map, oh yeah, this dot map dot set key and the value. Now I believe that should be everything. Let's see, it's not key, it's not delete. Okay, let's see if that passes. This map, oh I see, this dot map, sorry, let's see. So it's bigger than, okay, again, this dot capacity. Now that should pass. Let's see if that passes. Okay, the error here, so we're getting 3 and 4 don't exist. It's in the put function. So if this map has key, we can delete the key and then we set the key in value. Also, if this map size is bigger than equal to this capacity, this dot map dot delete the first value. Then we set the key and value input here. So why is it returning? Okay, again, so we're not pushing the values correctly, because as you can see here, 1, it says -1, but I should return 1. Here it says -1 for everything, which means the values don't exist. Maybe it's the pull function. Let's see. So if this dot map dot has key, oh yeah, we're not returning here, returning the map dot get the value for that key. Now that should pass. Again, this dot map, sorry, this dot map. Submit again. Perfect, you see it passes. Let's submit. And the time complexity has to be 01 average runtime for everything. As you can see, this one is just immediately deleting, which is 01, delete the key. And set it at the end. And returning it. So that's all 01, sorry. That is all 01. For the put function, we just delete the key. And then we set it. So again, that's all 01. And as you can see, this is average runtime complexity, and also beats most people for space. Thanks for watching.